All right, let's finish up chapter 5, or systems, picking up with number 9. They've graphed these two equations for you, so this is really easy. You're just looking for the intersection of where they cross. The coordinates of that are about 1.5, -2.5. Okay, so you're just kind of looking for coordinates more than anything. But I do kind of want to take this opportunity to show you. So the first equation is easy to enter, right? mx plus b. That's super easy. The second equation, some of y'all have figured out how to enter this in the calculator, some of you have not. So let me show you how to do this. If you do menu and then graph entry, you can look, okay, I want to enter an equation. I am looking at a line equation. It's not a parabola. It's not these other things that you won't even see until you're in Algebra 2 or Pre-Cal. So it's a line. And then you notice, okay, so you have the slope-intercept form, vertical line, which if you ever forget what the equation for a vertical line is, this is a good place to jog your memory. But this is that standard form, right? X and Y are on the same side of the equal sign, equals a constant. So I'm going to click on that. You notice it kind of sets up a base for you. So the number in front of the X is a 4. The number in front of a Y, this is where it's a little weird. You cannot change that from a plus. So we're going to have to enter this as a -7 so that it reads it correctly. And then I just have to enter 23 for the last one, okay? And then when I graph it, you'll see it matches the picture that they did. But that menu option is a good one to have in mind, okay? All right, number 10. Which system of equations has infinitely many solutions? You can just go through on this and enter them all with the menu 3-2, right? The solving systems of equations. I'm going to skip, well, actually, I'm going to show you one that might kind of throw you off because infinitely many solutions kind of shows up weird. Let me show you answer A and let you see what happens on this. So x minus 2y equals 4. 2x minus 4y equals 4. When it's a no solution problem, the calculator is going to tell you, oh, it's a no solution on systems of equations, okay? We already discussed it doesn't do that on the regular equations, but it will on a system of equations. Now, I know the answer to this is H, so to save some time, I'm just going to skip straight to H to show you what it does when you get infinitely many solutions. X minus 2y equals 4. Oh, crud. I hate when I do that. X minus 2y equals 4, and 2x minus 4y equals 8. Okay, you get this really bizarre answer, okay? This is kind of your clue that this is an infinitely many solutions, okay? No solution, it'll straight tell you. Numbers, it'll straight tell you. Infinitely many kind of ends up being this weird option. And you can always go through process of elimination, do all 4 of them, and the one that has the weird answer is the infinitely many, okay? All right, number 11. If the system of equations has no solution, what is the value of k? Well, one way I could do this is I could just go through over and over and over again and look at, you know, what this is, what number is going to work to make this thing no solution. I wish I could tell you a really easy way to reason through this, but basically a no solution is going to have the same rate of change. Like if the y value is doubled the x value, then this y value is double that x value. I know that's really strange. Now, if it's infinite solutions, you'll notice, look, it doubled, and this one also doubled, but notice how, like, my constant at the end also doubled. I know this is kind of a weird thought right here. No solution, you may have, okay, my x doubled and my y doubled, but my constants at the end stay the same or don't share that same relationship. So this one's kind of hard to explain to you, but if you just keep testing values until you get something that says no solution, you're going to find that putting a 6 right there is actually what works, okay? So it's +6 or 6.0. You could put them both in slope-intercept form and go with it that way too. Number 12, we've got a coin question. We have 355 in nickels and coins. The total number of coins is 5 less then twice the number of nickels. This is quite a bit more confusing than our normal one. So our unknowns is I have Q, the number of quarters, and N, the number of nickels, okay? First thing I know is I have 355 value. So when I'm dealing with that value, I've got to think about the value of a quarter and the value of a nickel. So quarters are 25 cents per quarter, and then I'm adding to that 5 cents per nickel. It's not 0.5, that would be 50 cents, 0.05, equals a total value of 355, okay? Now I've got to go through, okay, the total number of coins. So the total number of coins would be adding quarters plus nickels together. It says is, remember is your equal sign, so equals. 5 less than means I'm subtracting 5 from something. Twice the number of nickels, 2n, okay? So I've got, first let's look for the value one, because they know you guys are going to be suckers and fall for that. Don't do that. The value, these two have my value equation. 5 cents per nickel, 25 cents per quarter is a total of that. And then I just got to look at the other two. So there's my total number of coins. And they know you're going to forget that 5 less than something does not mean you are starting with 5 and subtracting. It means you're taking away 5. So the answer to that one is J. All right, one more question. Let's try and fit it in here pretty quick. We've got hot dogs and veggies. So my unknowns are hot dogs and veggies, all right? It says we got 4 hot dogs and 3 veggies for $27. Oh, my unknown is actually the cost of hot dogs and the cost of veggies. If I look, it tells me the price of a hot dog and the price of a veggie burger. So I know I can get 4 hot dogs and 3 veggies. Sorry, I was trying to use their variables. And that was a total of $27. Then it says this other person bought 7 hot dogs, and 4 veggie burgers, and she paid a total of $41, okay? So those are my 2 equations. Solving it algebraically, yeah, you could use elimination, you could use substitution, but guys, test day, I'm all about stacking the deck and doing the easiest thing possible. So let's just do a calculator document. Let's do solve system of equations. Let's go ahead and change this to H and V so that I've got my correct things. And then I'm just going to plug in 4H plus 3V equals 27. And 7H plus 4V equals 41. Oh, syntax error. Oh, do you notice how the cursor jumps to where I made my mistake? It's going to be nice and go ahead and tell you right off the bat so you can fix it. I don't need 2 plus signs there. And I get 3 and 5. So hot dogs, 3, veggie burgers, 5. Now, this whole interpreting the solution is just saying, what does that actually mean? Well, H was the price of a hot dog. And 5 is the V, price of a veggie burger. Yes, I realize I just wrote prive. Sorry. So the solution is hot dogs are $3 each. Veggie burgers are $5 each. Okay? All right, there you go.